Good day, everyone. Thanks for the people that subscribed so far. I really appreciate you. And today we go, in the previous lectures, we've gone through the basic syntaxes. Today we are going into the variable declarations, initializations, and by head sample. We're going to see them in demonstration. And before we begin, let's first look at a few slides we have here. The few slides we have here talks about variable. The variable is a memory location. It's just a memory location where value are being stored that can be reused. And that memory location is volatile, so it is stored on the RAM. All variable we declare with our data types. The size they accommodate on the memory is being determined by the data type we used. So below is how we declare variables in C++. Before, you can just use normal variable the way we use in maybe other Python or in our mathematics. They need to be assigned a type. Here we have age. Age is always a number, positive integer number. But here we still have int. So, but we're still going to look at the problem with this even int, because this int can still go into negative. And we don't have an age being a negative. Other numbers can be negative integers. We also have float salary. Salary to be declared as float. So that means we have your salary do have decimal numbers. You may think that salaries or decimal numbers are not even important. Well, let's take for example, if you have like 1 million customers and you have 0.5, 0.88, 0. And you multiply them by 1 million, you know how much you're going to get? So they're very, very important. We also have our what? We look at what? Declaration initialization. We have age equal to 15. Yes, salary is equal to 3,500.56. We have character B. So we also let's look at scope. The scope represents the block, the entire block in which that requires the lifespan of that variable. Once the program ends, the lifespan of the project of the variable also ends. When you call the function, you declare a function inside a function. You declare a variable inside the functions. Once that function has been invoked or is being invoked and is used, so the lifetime of that variable has already ended. So it's like within a block, the scope is like a block. You can see a function here. We declare a void functions here, int age. Our closing bracket is even missing. Apology for that. So once we call this get age, we can even later call it again, call the matrix of the age anymore. Yeah, the lifetime of that age ends there. We also look at the lifetime. Variable exists in memory for a certain duration, known as their lifetime. Local variables are destroyed. Any variable we declare inside the functions or inside the class is local to that environment. It's local to that block of code. Also have modifiers. Can have like modifier like static, instant, mutable, and so on. We're going to see them in demonstration. See the type of, let's move to the type of variables. What type of variable do we have? We have local variables. You can see the function, you can see get age. This age cannot be used in another function because it's local. It's local, started from this point and end here between these open braces and these closed braces. So we cannot access it here anymore. You can see, cannot be accessed. We're going to see that also in our demonstration. So let's look at global variables. Global variables, variables that are declared outside of the functions. They are declared outside of this. It can be outside of this integer here, preferable above of this get user age. So they can still be used inside the functions and in another function. So they are global within the scope once the program terminated. We also have member variables. They also can also be called instance variables. They belong to the instances in the object of a class. So for example here, we have each of the objects in a class has its own copy of variables. We have the member variables. All those variables we declare inside the what? Inside the class as known as the member variables. I'm going to also see them. We also have constant variables. They are declared with the keyword const. That means once we declare it, a value cannot change again. We cannot remodify the variable anymore. Don't be confused by the time we say mutable. Yet there's a way we can still modify mutable keywords with even const keyword. Understand? We also have mutable variables. This type of variables can be modified even if they are part of the object declared as const. For example, we see here, we have a mutable here, it's AJ. This mutable cannot work outside of the class. Cannot work inside maybe a function or you declare outside of that. They cannot work outside of the class of the scope. So here we declare it as mutable int age. Age of people can still change. You were 1 year old last year, today is +1. Your age can be what? Can only increase, not decreasing. We also have what? We declare it here, we now make it a const. We can change it. Since the class is declared as const, here we can now change the value, assign the value to it again as 25. Allow because age is what? Is mutable. If you look at Rust programming is talking about mutability and immutability. All variables are what? By default, they are immutable. They cannot change in Rust. That means if you want to change it, you have to apply append mutable to them. Like example, but here, like other programs, other language like Java or C++, they are what? Maybe private by default as well. So they are not visible to other outside world. So, but we are going to see them. Also have register variables. These are the compiler allocate this thing inside the CPU itself. So I make it easier accessible. Then you are working with memory, you are working with and that deal with processor, communication with processors. So I have to maybe you declare a variable. Regarding this variable, the variables here determine the kind of projects you are doing, you want to do. We also have instance variables. Let me just stop there. These instance variables is the pointer variables, reference variables. I'm going to be seeing them later on by the time we get to those topics. So because don't allow me to bug you with many, I don't want to bug you with many variable type and everything. When will I learn this thing finish? No. You learn them as you use them. You learn them as you use them. So we have data, we also have data types. We have before we move to data types, let's first demonstrate what we've learned so far. Let's open our VS Code, Visual Studio Code, and let's demonstrate some example of these variables we're talking about. Our previous class we have let's move all these variables here. Let's create a package, a folder, directory. Let's move them inside it. I just name that one. Let's move this and this. Let's move them inside this folder. We've moved them now inside the folder. Now let's create another folder. Part 2. Yeah, part 2 here is what? P2. That is variables. Variables. Start. Now we have here. Here, this one is basic syntax. Just let's rename it to syntax. Basic syntax. Basic syntax. Here. So let's move here. Part P2 here. Let's create a file here. Nothing inside yet. Come here. Create a new file. Let's name as variable.c. .cc.cpp. Then let's include our that one is we need to include it all the time. Contain our input output standard library. So include it here. IO include iostream. Also have our what int main return 0. All right, this is our basic structure, our simple C++ program. Now let's create some variables now. Let's create some variables, maybe local variables. Let's create it here. If I say this is int x and int, this is declaration. We declare this variable, declaration. This is s, this is variable declaration. So if I say, okay, int y, this is another what? Variable declaration. The same thing. But let's give, you can also give it a value. You can come later on and say, okay, x equal to what? Maybe 45. Here, you can also, here we declare variable as also as y. But let's variable declaration with initialization. Variable declaration with initialization. That means this is we initialize x here with initialize x here to 45. Right, we give, I mean, we assign the value of 45 inside x here. Here we now go ahead. Here we can also do the same thing on the same line. Variable with declaration. That means we have y is equal to what? Maybe 46. So we have 46. Now, this is, we declare the variable 46. We declare the variable here y to be y. We declare variable y and also give the value what of 46. Variable declaration with extension y now equals to what? 46. Then you can also create another variables. Int, maybe let's sum them. Let's call it sum equals x plus y. Don't forget this is a statement. You remember as our last class, it's a statement. Everyone here is a statement here. Just that once you end with this semicolon, it's what a statement here. The summation of the two values. Now let's sum it together. Let's display the result out from our standard library. We use cout to display value. We use cin to get in value. Cin is used to accept input from the user. We also use cout to what? To display value to the user. Then this is cout. Cout is sum. Sum. We add into what? Add a new line to it so that our system will not attach it with our console something variable. So we have this here. Let's compile it now. If you compile now, you can see we get 91. We run it, or you can just come here, come to your terminal, and just say, okay, that's it. It has given me a name as variable. It gave, can see once when I run the cop, if I click, let me delete it again. You can see, let me delete it here. If I compile it again here, it automatically generates it for me. But let me also run it with a normal command. The flag here means O, means output. If you also want to just compile, means C. You just compile. So I also want output value, want to output value. Then we also have what? We give it a name. The other time we gave it a variable, but here let's call it a name. Let's just call it, because like a binary file. It's going to be a main binary, because it's a binary file now. And what's the name of the file? The name of the file is what? Variable cpp. Can you see? We have an issue here because we are not yet in directory. See, I'm inside this directory here. YouTube document, cpp, something. So we need to change to our directory. cd p2. Now, I'm there now. Now, let's recompile. Use your arrow button to go up a little bit. Then I have it here. Compile. Good. No error. That's our word. See the name here. Main binary file. Give it a name here. The same thing. Now run it now. Main binary tab it. You run it. You get what? You get 91. Just as simple as that. Let's declare variable x and y. We assign value to them here constantly. Let's accept value from user. So the program will allow user to what? Enter the first value, enter the second value. Then we're going to sum the two values together. Then we're going to what? Display the result. Let's try and do that now. Let's leave this our variable here. Let's stop giving them what? Look at it here. So you can also declare it here. You can have them here declare in the line. You can say, okay, it's maybe if this one is S2, this one is S. Let's call it this one S1. You can call it anything. Let's call int what? Int sum, right? You can also have everything like this. Int x1, x2, sum equal to 0. You can also have everything declared this way. So declare everything this way. If I also comment this one, if I remove this one and leave it this way, it's going to work. Understand? I'm going to put a comma here. So let me remove it. So I go to C. Comment it there, Control /. You can see it's still going to work. Now you have everything on a single line, terminated with what? With semicolon. All right. For easy understanding, let's leave it the way we did the first one. S1 here. Then remember what we want to accept value from the user. Understand? We now assigned. Let's get the user. Let's first tell the user so that if we don't tell the user the information, okay, if I run it, let me firstly compile it. Then you will see what I'm talking about. std cin the other one, this one is a output operator. Our input operator here, just use this one to receive value and store it inside our variable. Understand? Maybe, sorry, S1. Okay, then the other one was std cin we store inside our what? S2, taking the value. Then we now sum equal to what? S1 plus S2. In case you are bothered about this error that is showing, I told you last class, go to the market and you search for it. It's going to come out. Search for error lens. Error lens is going to come up. I'm not on internet now. Error lens is good. You're going to install that package. Go to enable those error highlighting to be coming out. Then let's sum it now. Let's run the program now. Let's clear this. Let's recompile. You have to recompile. Compile. You've compiled it. Now you see something. It's already blinking, expecting you to enter something. But we never told the program to start. The user is going to be what? Because the same is running. Is he running now? Is he running? 89. Enter 89. Second time again. 47. 46. 46. Pardon me. Can you see? 135. But we can make it better by telling the user so that the user is going to know what is going on. Enter the first value. Here again, yes. To avoid all this STD, you can just include But don't worry, I will explain later when time we get to the program. It's namespace. Namespace, you just come here using namespace. It's going to include them from all the namespace, std. It's going to import everything that we needed. So we don't need to be using std anymore. If you just import it once and for all, understand? If we don't need to use those namespace already included inside our namespace. This is it here. Just you don't need to. So it has imported all those library there. So let me remove it. Still using it again doesn't have any problems, but just to reduce the number of code you are going to write. So let's just store CIN1. Now enter the value of value 1. Install it here. Cout. Enter the second value. You can see now we store the second value here. Now we now sum it there. We want to sum it, but I don't want any. I'm going to tell us later, step by step. Where you can go to appending of strings, and then we move our data types. Yes, actually, I will tell you that appending of strings with integer to be able. But let's sum our result now. Let's recompile it. Let's compile it again here. Let's recompile it now. Let me run it. Can you see now? Enter the first value. 1898. 23. We have 121. Can you see? Second value just was the result. You can also say the result is. You can just put it here. The result is, or you can just append it here. Cout. The result is this. But mind you, I want it to come together. I can just remove this. I don't want to end with end line. So just remove this. If you see now, let's recompile again. Remember, we've removed end line from here. So it's going to put everything on the same line. 87, 56. Can you see? The result is 143. But mind you, we have end line here. So therefore, these variables are they are local to these variables. They are local to this function main, the default main. But you can also have another variable. For example, pi r square. Maybe we want to get a value of pi r. The area of a circle, maybe pi r. Okay, let's just name it as what? This is what? Constant. Let's call it constant. Pi float pi equals this. Equals pi equals what? 3.142, for example. Then we now come in. Let's get the area of a circle. Let's ask, instead of the user saying that let's comment this out. Pi r. Pi r. Let's ask the user to enter what is the radius. Maybe the radius, let's just make it float. Radius. CIN. Just a 40 Cout. Tell the user that what it should enter. Enter the radius of a circle. We have it here, just like this. Enter the radius of the circle. Of the circle. So just come here. Then we move down here. And the enter. If we don't assign it here, we're going to see nothing. Let's compile it. Let's see. Let me clear this. Let me compile. And you see, enter the order of the circle, because we've not our CIN operator. We've not assigned variable to it. So we now say what? Radius. You store the value inside the radius. Then we now say, okay, maybe float results. You give it a float result equals what? Pi. Can you see? We make it as constant here. We cannot change the value. Understand? For example, if we want to tell, let's check it. Maybe we can change the value. Let's try to check. Let's increase pi here. Pi plus. Can you see? We even have there's a one that what expression must be what? A modifiable integer. If I remove it and change to what? Int. Can you see? The error has disappeared. Understand? But that's because we don't want the value to change. Constant means constant. It should remain the way it is. Then we should have it this way. Then we have pi multiply by what? The radius. Understand? Then we have our result. Then our just see out the area of a circle. I think it's pi r squared, right? So maybe pi r squared. That means our radius is into maybe let's. I don't want us to use any library now. Let's maintain what we have now. If it is pi r squared, that is a bi multiply what by that's r. So we have it. So area of a circle. Then we terminate it here. Then we see out results. Then we now have our result equals this. And sorry, I don't know what's happening to end line. So we have it this way. Now let's compile now. Let's run. Let's clear this first. Let's compile. We have error here. What is the error? Okay, this. It's forgotten that logic. So we have it here. Then we have clear once again. Compile it. We now run it. Enter the radius of the circle. Then we have maybe the radius of the circle is just 5.7. Let's just give the 5.7. So the area of the circle is what? This multiplied by this. It's a 5.7. How can it be? Then 5.7 times 5.7. Understand? 5.7 times 5.7. You know what the result will be. Then multiplied by what? 3.142. That's how our result will be. Understand? So maybe we should stop here. We continue from the next lecture. Thank you very much. Have a wonderful day ahead.